Hello everyone. So let us continue our discussion with the power of lens today. So power of lens is defined as the reciprocal of focal length, right? It can be a convex or concave lens. It doesn't matter. The power of a lens is 1 upon focal length. Now depending on sign of focal length, the sign of power will be defined, right? And first of all, you need to understand that it is nothing but the defined as 1 by f, where please mind that f is in meters, right? It means that f should be in meters, right? And the unit of power of lens is unit of power of lens is diopter, right? And it is represented by capital D. Suppose the focal length of a convex lens, right? The focal length of a convex lens is, let us say, 100 centimeter, right? Convex lens focal length sign is also plus. So convex lens focal length is plus 100 centimeter, which means 1 meter. In meter, if I convert this, it is 1 meter. So what is the power? Power is nothing but 1 upon 1. This should be in meters, right? That is why we need to convert this centimeter into meter always while calculating power of lens. So this is what? 1 diopter plus 1 diopter, right? So what is defined as the 1 diopter power of a lens? When a focal length, when a convex lens, or when a lens of when a lens when a lens has focal length equal to 1 meter, then the power is what? 1 diopter. If it was a convex lens, suppose this was a convex lens, in that case what would have been the power? The power would have been, in case of a concave lens, let us see. In case of a concave lens, what would have been the power? The focal length, suppose it was minus 100 centimeter. So F is in meter is minus 1 meter. So now the power will be minus 1 diopter, right? So a negative sign is for concave lens. So this is the meaning of the power of lenses. Now what can be happened is that these lenses can be used in combination, right? One lens can be used in combination with the other lens. So we need to calculate the equivalent power of that optical system. Suppose I am telling is, suppose this is a concave lens, right? This is a concave lens, and near to this concave lens, like this, it is attached. A convex lens is placed, right? This is your lens 1, this is your lens 2. And suppose the power of this lens is what? P1 is equals to minus 2 diopter, and the power of this lens P2 is plus 1 diopter. So if I talk about this total combination, so the total power will be what? P1 plus P2, right? So this will be what? Minus 2 plus 1, that is minus 1 diopter is the power of this system, that you need to understand. So this is how combination is considered. Suppose there are n lenses, so power will be what? P1 plus P2 plus P3 plus up to En. Okay, so this is the meaning. It the lenses can be concave, convex. Accordingly, according to the sign, the power will be getting plus and minus. So this is the meaning. Okay, and if he wants to ask you about the net focal length of the system, so you know that power is equals to 1 by f. So if the focal length of the net focal length of the system is 1 by f1 plus 1 by f2 plus and so on. And remember that, please, this focal length should be in meters. This is important, right? So this is what we saw about the power of lens. So now you know about the power of lens also. This was the only topic which was remaining. Now we will be continuing on the numericals based on this refraction part. So some good problems we will be seeing today to build concepts on the refraction part, right? So let us move further, and let us the first question, see the first question, right? So a ray of light incident on a glass slab at an angle of incidence 60 degree. Okay, he's telling that this is a glass slab. Suppose this is a glass slab. Okay, this is the boundary. Okay, so angle of incidence is what? 60 degree. Angle of incidence 60 degree means, suppose this was your normal, right? This was your normal. This was your normal. This angle is what? 60 degree. This is your incident ray. He is asking if the angle of refraction be 32.7%, 7 degree. Okay, 32.7 degree. So he is telling that now it is incident on a glass slab, right? So now the angle of the refracted ray will be like this. Since this is what? This is your air and this is your glass. So this is your denser medium. So obviously, if roughly we draw the ray diagram, this is going to be the bending towards the normal, and this is your angle of reflection, right? So he is telling that angle I is equals to 60 degree and angle R is equals to what? 32.7 degree. So he is asking you, what about the refractive index of the glass? He is asking what is the refractive index of glass. And we know the refractive index of air is 1, right? Now, according to my sign convention, and according to my Snell's law actually, so according to Snell's law, what do you know? That n to 1, the refractive index is sine of I upon sine of R. Now you can see that the traveling to medium is what here? Glass. The second medium is what? Glass. The first medium is what? Air. So we can write from here that this is what? In place of 2, we will be writing the glass. Okay, glass and air is we represented by 1. So glass, a refractive index of glass is what? Sine I upon sine R. So sine I we nothing know. We know that sine I is what? 60 degree. Sine R is what? The value of reflection, angle of refraction is sine 32.7 degree. So you just need to put the value. So what is the value of sine 60 degree? We are given as 0.866, right? And what is the value of sine 32.7 degree? 0.54. So if you calculate this, right? If you calculate this, uh, let me solve it on the your quickly. Let us calculate on the. So it comes out around to be 1.603. Okay, so this is around 1.6. So we get Ng is equals to 1.6, right? So this is your answer. Now one thing I need to tell you before I move further, this question is clear, right? Now I want to tell you another relation from this question. Okay, now what I am telling is I have told you already about the absolute refractive indexes. Okay, this is your medium 2, right? This is medium 2 and this is your medium 1. Ray of light is traveling like that, right? And it is going like this in the medium 2. So you call the refractive index n21, right? This is what? Speed of light in medium 1 upon speed of light in medium 2. Okay, if I take the first medium, that is if this medium is taken as vacuum, or for that matter if we take it as air, so we replace this one by simply nothing, and to we call, and in place of c1 we write the speed of light, which is c, and this c2 remains intact, right? And similarly if we take this medium, okay, if we take this medium, suppose this was not, now we consider another case, this was not vacuum or air, right? Now this is first medium, so according to this I can write also for this first medium, this medium is something else than air or vacuum. Then we can write similarly from this n1 is equal to c upon c1, right? So this is your first equation, this is your second equation. So if I divide your 1 by 2, what I get? N2 by N1 is equals to what? C upon C2 upon C upon C1. So this is what? C1 upon C2. Right? The C gets cancelled out and 1 by C2 and C1 get on the numerator. So N2 by N1 is nothing but C1 upon C2. So this is also what I have wrote. Right? N21 is equals to C1 upon C2, and why what we got C1 by C2 is N2 by N1. So that means what? N2 by N21 is equals to N2 by N1. This is the meaning. This is the relation which I wanted to tell you. So what I want to tell you is that suppose we are talking about the refractive index of second medium with respect to the first medium, right? Refractive index of the second medium with respect to the first medium, then it is nothing but the ratio of absolute refractive index of second medium with the first medium. This relation is important and will be used. Suppose this is your glass and this is your water, so you will replace by n. Second medium is traveling to is water, so water glass. So this will be n w by ng. Okay, water to glass, refractive index of water with respect to glass is what? Absolute refractive index of water with respect to absolute refractive index of glass. So this is the meaning which I wanted to tell you. Okay, so this answer is, this question is clear, I think. So let us move forward with the next question. Now it's telling light enters from air to diamond, right? Suppose your two medium is diamond and air. From air the light is entering, right? And diamond has a refractive index of 2.42. So he's asking us calculate the speed of light in diamond, right? So according to this, N21, right? What is it? C1 by C2. So we know that 2 is what here? Our diamond only, right? And 1 is what? Air. So it is N equal to C by C2. So this is C we know, and D we know. So we will just use the value here. So 2.42 is nothing but 3 into 10 to the power 8 upon, because speed of light you know, 3 into 10 to the power 8 meter per second. So this C2. So what is the value of C2? We will calculate this, right? So if you calculate this, 3 upon 2.42, right? So let me calculate it quickly. So it is around 1.239, right? 1.239 into 10 to the power 8 meter per second. So this is the speed of light in diamond. Now you can see that this was the speed of light in air and this is the speed of light in diamond. So which is lesser? C2 is lesser. You can easily see that C2 is lesser because diamond is a denser medium and air is a rarer medium when compared to diamond. So what is happening? You are obviously getting the speed of light reduced in case of diamond. So that is the meaning. Understood? So this is how you will be solving the sum of the question. Now let us quickly move it to the next question. Right. Two lenses are in contact and the focal length of the combination is 80 centimeter. So two lenses are two lenses are in contact. If the focal length of one lens is 20 centimeter, find the power of the lens. So he's saying that two lenses are used in combination. So we don't know which lens it is, convex or concave, we don't know, but this is L1 and L2. So he's telling that the focal length of the combination is 80 centimeter and focal length of one of the lens, let us see, this is f1 is equals to 20 centimeters. So he's asking what is the focal length of, or what is the power of this lens, right? So we know that focal length of one is 20 centimeter. And what about the power of lens? The total power is what? P1 plus P2. So if I write in terms of focal length, this reduces to what? 1 by f total is 1 by f1 plus 1 by f2. So we will just put the values 1 by ft. Now listen, 80 centimeter we will be converting into meter. It is 0.8 meter. 20 centimeter we convert into meter, 0.2 meter. So we will be using that value only in power case. Okay, use meters only, right? That is always a better way to calculate power, because there can be some mistakes made by you if you don't convert this into meter. Okay, always have an habit of converting this into meters while using the power formula, right? So 1 by 0.8 is the total power, is the focal length of the combination. So 1 by 0.8 is the combination of the, is the power of the combination, and focal length of second is 1 by 0.2 plus 1 by f2. So this is what? This is nothing but the power only. So 1 by 0.8 is equals to 1 by 0.2 plus P2. So you can write P2 is equals to 1 by 0.8 minus 1 by 0.2. So if you calculate this, you will be getting 0.2 minus 0.8, that means minus 0.6 by 0.16, right? So this will be what? This will be 6 upon 60 upon 60 upon 16, right? 60 upon 16, because you will multiply with 100 in the denominator and 10 in the denominator to get rid of this point. So 60 upon 16. So this is equal to what? Right. So this is what? 30 by 8 is what? It is around 3. Obviously this is negative 3, and 7 times I think it will go, yes, 75. So minus 3.75. So what is the power of the other lens is? Power of the other lens is minus 3.75 diopter. So can you comment on the type of lens? The power is negative in this case. Negative means the focal length of this lens is what? Negative. So the focal length of this lens is negative. It means it is a concave lens. Suppose he would have asked to mention this type of lens also. So which type of lens it is? It is a concave lens. It is a concave lens. So that is the meaning. Right. So this is how you solve power question. Now let us move to the next question. An object 50 centimeter tall is placed on the principal axis of a convex lens, right? So what is U? Not U. It is giving the height of the object. So what is H? H is 50 centimeter. Its 20 centimeter image is formed on the screen. So on the screen means it is a real image. Convex lens he is giving and he's mentioning it on the screen. It means it is a screen he mentioned, right? So this means it is a real image, because a real image can be taken, and real image you always know it is inverted image. So if it is inverted upside down, that means H dash will be what? It will be negative. So he's giving its 20 centimeter image. So his 20 centimeter will be negative, because if this is like the, if the object is like this, AB, then the image will be upside down, A dash B dash, because the image is real and real image is always inverted. So 10 centimeter from the lens, the screen is placed. So we know that if it is a real image, inverted image forming on the screen, it is on the right hand side of the lens. So like this, suppose this is the lens, so inverted image is like this, right? So this V will be positive. So what is V? is giving distance of 10 centimeter from the lens, so 10 centimeter, right? Now we know m is equals to what? H dash by h. So it is minus 20 by 50, which is minus 2 by 5. And we know this is also v by u, right? So he's asking to calculate the focal length. So we know that 1 by f is equals to 1 by v minus 1 by u. So we need to put the values of v and u here. So if we know v equal to 10 centimeter, we will use this relation to find the value of u, right? So what is u? U is what? 5v minus 5v by 2, which is minus 50 by 2 is equal to minus 25 centimeter. Obviously this u will come out to be negative because of the object will be placed on the left hand side of this optical center. So this is your u, which will be negative. So it is coming minus 25 centimeter. Now we just need to put the values. So v is what? 1 by 10 minus u is what? Minus 25. So minus minus becomes plus, right? So this is what? 25 plus 10 upon 250. So this becomes, if I find the focal length, so this will get reverse. So 250 by reciprocal of this we will be taking, and this will be 35. So this will be 50 upon 7. This will be 7 7 are 49 times, and 1 7 2 are 14 and 6 7. Wait a minute, right? 1. So 1 times 3 will be winning. So yes, 7.14 centimeter is the answer, right? 7.14 centimeter you are getting the focal length, correct? So this is how you solve the question. Okay, let us move to the next question. An object is 2 meter from a lens which forms an erect image 1/4 the size of the object. So he's telling, he's not mentioning, we need to determine the focal length of the lens. Which type of lens is this? Okay, so what he's telling is u is what? 2 meter. Okay, and he's telling that erect image. So erect image means what? Erect image is what? Virtual image. Okay, it is virtual image, right? And virtual image means what? Magnification is, he's giving 1/4 size of the object. So m is 1/4, the sign will be plus because it is an erect image which is a virtual image. So we will be taking m equal to plus 1 by 4. So he's asking us the focal length. So we know what is u, so we can find v by this. So m is also equal to v by u in case of lens. Okay, remember to use v by u only for lens. For mirror it will be minus v by u magnification. For lens it is v by u. So we know the value of u. So from here v will be what? U by 4. So this is equal to what? 2 by 4, which is 1 by 2. Right? So v is equals to 1 by 2 meter. Right? Now what we will be doing? We will be just applying the lens formula 1 by v minus 1 by u. Remember this 2 meter is saying, first of all we need to consider the sign 2 meter from the lens. That means u should be taken as negative. Okay, I forget the sign convention, but u will be minus 2. So if u is minus 2 meter, right? So this is minus 2. So this is minus 1 by 2. So v is also negative. You can see v is also negative. That means it is like this. If this is your suppose lens, we don't know what lens it is. It is a virtual image and it is on the same side of the object. So it is virtual 1/4 size. So it will be diminished. Let us say like this. So if this is the object, this is your image diminished and it is on the same because u is also negative and v is also negative. So this is on the left hand side of the lens only. Okay. So now we will be finding the focal length, right? So this is 1 by f is now equal to 1 by v, which is minus 1 by 2, and minus of minus will become plus. So plus, obviously this becomes 1 by v. So this becomes uh, 1 minus 2, right? Because 1 by v we need to put, and minus minus will become plus, and this will be 1 by 2, right? So this will be minus 4 plus 1 by 2. So which is equal to minus 3 upon 2, right? So we need to uh, find the focal length. So it is minus 2 by 3. So you will be dividing this, right? So you will be getting 0.6666 meter, right? And you are having a negative sign. So negative sign means what? It is a concave lens. It is a concave lens, right? So this sign of focal length is giving you the type of lens. So you can draw the ray diagram also. If he is asking you to draw the rough ray diagram also, you can draw accordingly. We have considered the ray diagram. So this is what uh, the focal length is 66. If I this is 0.66 meter, right? So the focal length is 0.66 meter. So this is placed very far away from the focal length, right? So that case we consider only in the concave lens, right? So this is your solution to this question. We just need to use the proper sign convention in case of numericals. Sometimes in generalized expression, we just put the whatever the unknowns are there, and later we put the values. And in numericals, what we do, we directly put the sign. Yeah. Now see this question. Sunlight takes 8 minutes 20 seconds to reach the earth. Right. So we know that if it is earth and sun, the distance between this, okay, suppose we don't know, so the time taken is 8 minutes 20 seconds. So if I convert this into seconds, so 8 minutes will be multiplied by 60 seconds, so this is 480 seconds, and another for 20 seconds we have, so we will be having 500 seconds. That means in 500 seconds the sunlight is reaching the earth, right? Now he is telling what? If the entire space in between is filled with water. So now this case is what? Air. The light will take, how much time the light will take. So he is mentioning take this refractive index. So now let me tell you this symbol also, right? So this meaning you read it as refractive index of water with respect to air, right? You read this as refractive index of water with respect to air. So in our sign convention, if we write, it is NWA, okay, which is 4 by 3, right? So air we take it as 1 only, so I can write refractive index of water as air is taken as 1, this is 4 by 3, right? Now I also know that N2 by N1 is C1 by C2. Now suppose C2 is what? Here your water, and 1 is air, so this is what? C upon CW. So what we need to find is time. Okay, so we know the speed of light in air, right? We know the speed of light in air. So speed of light in air, we know that first of all, distance is equals to speed into time. So in the first case, we know the time taken is what? 500 seconds. And the speed is what? Because first initially it was air, so speed of light, it is c, which is 3 into 10 to the power 8, or I can write it as c. That is, the distance is what? The distance is what? 500 c. So this will remain same. Okay. So now what I do, let me rub this for you. I will write it. So we know that we can find, if we know the speed, okay. So in water, what will happen? The distance is what? Speed of light in water into time taken in water, right? This d we know. This cw we need to find it from here. The cw we will be getting it from here, right? And then I can find the value of time. So what is cw from here? Cw is nothing but c upon nw. And what is NW? NW is what? 4 by 3. So C upon 4 by 3, that means 3C by 4. So CW is what? 3C by 4. So I will use it here, right? So D was 500C, CW is 3C by 4 and TW, right? I will be now solving this. So TW is what? 500C into 4 upon 3. So this 3 get cancelled and this is 2000 by 3. So if you calculate this, this will be 3 6 18 and again 6 and again 6.66 seconds. Why? Because everything was in meter per second. Meter per second, this gets cancelled out, right? So this you get in seconds, right? Because this time I calculate 500 seconds, right? So this everything, this will be in meter per second. Meter per second will be cancelled from this C. So this only will be unit left is what? Seconds. 4 and 3 are constant. So unit is in seconds. So you will convert this into minutes, right? So this is what? 666. If you divide this by 0.66, this you will divide by 60. So it will be 60 times and again 60 times. Yes, 7.6. So it will be 11 minutes something, right? So straight away you can see it is B option. 11 minute and what? 0.66. So 0.66 is what? 11 minute and 6.6 seconds, right? Because this now end is in minutes. So 11 minutes, and if 11 minutes you convert into seconds, so 11 into 60 is what? 660. So we are left with again 6 seconds more. So 11 minutes 6 seconds. So this is your answer, right? So we did nothing here. We just used this refractive index formula, okay, and relation between speed of light and refractive indices. Okay, so this is how we solve this question. Now let us move to the next question. Okay, so this is your assertion type question. From the understanding of Cartesian sign convention for reflection by spherical mirror, a student took part in group discussion for FA1 in classroom. Okay, who is wrong in the group discussion? So these 4 people are here. You need to tell who is wrong. So first one is saying all the distances are measured from the pole of the mirror parallel to principal axis. Okay, if this is your mirror, this is your pole. Okay, pole is considered as the origin. So he is telling that all the distance are measured from the pole of a mirror parallel to the principal axis. Yes. So distances, yes, distances can be U, V, and F. Okay. So this is calculated with respect to this P only. Okay. So he is correct. The distance measured in the direction of incident ray are taken positive. Okay. Let us consider this. I am taking incident ray like this. So incident ray is like this, and we, if the object is here, so we measure U like this from pole. We measure U like this. So we take U as negative. Okay, so against the direction of incident ray, we are taking negative. And suppose if this is the, let us say, refracted, suppose we are telling now, what is the, suppose this is now reflected ray, right? Let me draw clearly. So this is the incident ray, right? This is your incident ray. And now what will happen? Now again, suppose because now suppose we are tracing back. Suppose this is a case of a virtual image, right? there is a case of virtual image, then we backtrace the rays, right? Suppose this is a reflected ray, then we backtrace these rays. So now if we backtrace and if a virtual image is formed, then we measure V from this pole in this direction. In this direction, which is similar to this incident ray direction. Okay, this is incident, this is direction of V, and this is direction of incident ray. We are measuring V from here to here. An incident ray is like this only. So this time also, we take V as positive, right? Yes, it is correct that incident ray direction, we take the sign as positive. So distance measured in the direction of incident ray are positive, against the incident ray are negative. Okay, she is also correct. The height measured, upward and perpendicular to principal axis is taken negative. So this is, you can know this is wrong. How? Because he is still telling that perpendicular to principal. So this is your principal axis and you are taking perpendicular to this and upward. So perpendicular to this, upward to this, I told you this is origin. If y axis I consider like this is upward direction. So upward direction is taken positive, not negative. This is wrong. The height measured downward and perpendicular to principal axis taken as positive. No. So these both are telling the opposite thing. So downward is taken as negative, right? So she is also wrong. So these two persons are right. So this point is important, that the distance measured in the direction of incident ray are taken as positive. Suppose I am telling that this is your principal axis and this is your pole and this is incident ray. So if it was forming a real image, somewhere here the image would have been formed, right? So now what happens if the image is formed? Now if we take V now we will taking as negative. Why? Because we are measuring V from here to here and it is the against the direction of incident ray. So this statement is correct and you should remember that the actually in the direction of incident ray, the taken quantities are, the measured distances are taken as positive, whereas if it is against the incident ray, it is negative. Okay, so this was one of your conceptual questions. Let us move further. When light falls on a given plate at an angle of incidence 60 degree, the reflected and refracted rays are found to be normal to each other. So what is happening is, now you need to consider is that there is a plate, right? And this plate is what? This surface is such that the reflected and refracted rays are both are there. That means refraction and reflection both is happening. So angle of incidence is like this. Suppose this is the angle of, this is your incident ray. So he's telling that, and if this is your normal, right? This is your normal. So angle made by this incident ray to the normal is 60 degree. So he's telling that some of the rays will get reflected back, right? And this is your first medium, this is your second medium, and he's telling that refracted and reflected rays are found to be normal. So it means, suppose this is your refracted ray, right? So somehow angle between this is 90 degree. This is your what? Reflected ray, and this is what? Refracted. So angle between these two is found to be 90 degree. That is normal to each other. So he's asking what is the refractive index of the material of plate, right? So he is mentioning that the light is falling on a given plate. So we need to consider the first medium as air or vacuum only. So this N2 is what? This is plate, right? So we know what? NP is what now? NP is what? It is sine I by sine R, right? So this will be the refractive index. So first of all, we need to find this angle of incidence. We know we need to find this angle of refraction, this angle R, say. We need to find out, then we will be able to calculate this refractive index of plate, right? So now you know this has 60 degrees. So by laws of reflection, this angle is 60 degrees. So by law of reflection, now this angle is also 60 degrees, right? This angle is what? 90 degree. Okay, because this angle between these two is 90 degree. So if I consider this complete angle, okay, this complete angle is what? 180 degree. Amount, this is 60 degree, this is 90 degree. So this is what? So R is what? 180 degree minus 90 plus 60 degree. So this is what? 30 degree. 90 plus 60, 150. 180 minus 150, 130 degree. So angle here is what? 30 degree. Now I will use in this formula. So NP is what? Sin I means sin 60 degree. And sin R is what? Sin 30 degree. So root 3 by 2 is nothing but your sin 60 degree, and sin 30 degree is 1 by 2. So these two gaps cancel out. We will be left with 1.732 is the answer, because root 3 is what? 1.7. So what is the refractive index of the plate? It is 1.732. How we wrote this? Because I told you that refractive index of N21 is what? This is sin I by sin R. Now in this case, the traveling to material is plate, and traveling from, we consider it as air or vacuum because nothing mentioned. So this is N1 is air, so we write 1 instead of when we drop out this one, and 2 we are writing as plate. So I got this formula, right? So this is how we solve. Now let us move to the next question. Yes. A ray R1 is incident on the plane surface of the glass slab kept in air of refractive index root 2 at an angle of incidence equal to the critical angle for this air glass system. Now I need to explain you what this critical angle is. So listen here carefully. What happens when ray of, suppose this is your boundary condition, and this is your first medium, this is second, and this is denser medium, right? And this is rarer medium. And suppose this is your normal. Now what happens? If I make a ray incident on this, obviously it will be bending away from the normal. Again, if I increase this incident, angle of incidence is like this, okay? Suppose I increase angle of incidence like this, again what will happen? It will again bend away from the. Now again what I do, I increase, this was the second angle of incidence, I1. This is the first angle of incidence, this is second. Now suppose I make angle of incidence here, right? This is now your I3, angle I3. Now what will happen? It will bend further away from the normal, and it will follow this surface path. This is your refracted ray now. Okay. So this I3 angle is what? It is a critical angle of incidence. It is what? It is a critical angle of incidence. So what is the critical angle of incidence at which the refracted ray is on the surface of this boundary, okay, of this both the material, the surface is boundary, the refracted ray path is on the boundary of this denser and rarer medium. Or you can say that the angle of refraction is what? Now the angle of refraction is what? This is where your normal, this is your refracted ray. So angle of refraction becomes 90. So angle of refraction becomes 90 degree. So what is the meaning? The angle of incidence, when first of all the condition is that the light must go from denser to rarer medium, and in that case, when angle of incidence is such that the angle of refraction becomes 90 degree, right? The angle of refraction becomes 90 degree, then we call it as what? Then we call it as what? This angle is incidence is what? Critical angle of incidence. And now if I write the Snell's law, so what is the Snell's law? It is N21. It is sin I by sin R. Sin I by sin R. So what I can write? Sin I will be what? Sin I will be what? It is sin IC. And it is what? Sin R is what? Sin 90 degree. And sin 90 degree is what? It is equal to 1. So this is sin IC by 1. And N21 is what? It is nothing but denser. This is your formula. N21 is what? sin IC by 1. And n21 you can write it as, what you can write? I told you can write it as n2 by n1, right? You can write it as n2 by n1, because this is what? C1 by C2. And we write C1 as what? We write C1 as what? C by n1, and this at C by n2. So we get n2 by n1. So that is why I am telling that this is n2 by n1. So n2 by n1. So if the so this is the meaning, right? So rarer medium, if it is, say, let us air. If the rarer medium is air, then 1 by n1 is equals to what? If this becomes air, this becomes air, then n2 is what? Air. And for air, the refractive index n2 will be 1. So 1 by n1 is what? Sine. Understood? So that is the how the Snell's law get modified when we talk about the critical angle. Okay, so this is the point which I wanted to tell you. So let us now go back to this problem. Right. Now let us get back to this problem. Now he's telling that R1 is incident on the plane glass slab. This is your glass slab, green colored, kept in air of refractive index √2 at an angle of incidence equal to the critical angle for this air glass system. So if so these the angle he is taking is equal to the critical angle of what would have been in the case of this glass and air interface. Suppose this ray of light was passing from glass. So if the refracted ray would have been such that way, that angle of reflection would have been 90 degree. So whatever the value of this angle is, he is taking it at here. So what is the meaning? So I told you that what is happening? 1 by n2 is what now? Air. In this case, n2 is what? Air. N1 is what? Glass. So n2 by n1 means n2 by n1 is equals to sin n by sin r. If it would be in this case, we are not taking this case, we are now finding this IC relation. So this would have been case he is taking air glass system interface, critical angle for air glass system. So this would have been the typical air glass system when the light was traveling from glass to air. In this case, it is traveling from air to glass. So but the angle he is taking is equal to the critical incidence angle, which would have been the angle if this light would have been traveling from glass to air at a critical angle. So we are calculating that angle, right? So he is telling sin IC if it is the case. This is n21, right? Now the first medium would have been glass in this case. So 1 by n glass, because n2 would have been air in this case. So 1 by ng is equals to sin IC upon sin r is sin 90 degrees. So this is nothing but 1. So sin IC is what? 1 by ng is giving it as √2, refractive index of √2. So 1 by √2. So you know that sin theta degree is equal to 1 by √2 when theta is equal to 45 degrees. So IC is what? 45. So that means with this angle equal to 45 degree, this ray is becoming incident, right? So this angle is what now? So now sin I by sin R, in this case, now we know the value of angle I. And in this case, what is happening now? In this case, this was for the calculation of the critical angle, right? Now where the light is traveling? The light is traveling from air to glass. So light is traveling from air to glass. This was your air first medium, and now it is traveling to glass. This is medium 2. So it is what? It is Ng by Na. So this is what? Sin I is what? Sin 45 degree upon angle of refraction, you don't know. It is sin R, and this is Ng, which is equal to √2. Right? So sin 45 degree is what? 1 by √2. So sin 45, I can write this as, let me clear this for you. This is clear, right? So what I would write? So Sine r from this I can write sine r is equals to what? Sine 45 degree by sine r is what? Sine 45 is 1 by root 2. So 1 by root 2 into 1 by root 2. So this is 1 by 2. So sine theta is equals to 1 by 2 when the theta value of theta is what? Value of theta is what? It is 30 degree. So angle R is what? 30. So this is your, this angle is your 30. So if this is 30 degree, then these red colored lines are parallel lines and this is your transversal. So this angle will also be 30 degree. And he is asking us to find the angle between, so this ray is going in the partial reflection. Okay, at this surface, reflection is also happening in the form of R3 and refraction is also happening in the form of R4. So he's asking the angle between reflected ray R3 and R4. So he's asking us to find this angle. Okay, this is 30 degree, this is 30 degree. And again, if this is 30 degree, it means that this angle is what? Also 30 degree, because angle of incidence equal to angle of reflection, because this is your reflected ray. So this is 30 degree, right? This is 30 degree and this is what? This angle is 30 degree. Again I can find this angle. So what will be this angle? We need to find this angle. So again we will be using the formula of this one, right? Again we will be using the formula. Now what happens? Sine I upon sine I upon sine R, right? And this is equal to what? Now the your traveling to medium is what? Air. So an air by, from it is traveling from glass. So this is equal to I is what? 30 degree. So sine 30 degree upon sine R is equals to what? Na is what? 1 upon root 2. So you can find the value of sine R from here. It is root 2 sine 30 degree. So this is what? 30 degree is what? 1 by 2. So this root 2 will be cancelled out. So it will be 1 by root. So this is angle is what? 45 degree, because sine R is equals to 1 by root 2. Then angle R is equals to what? 45 degree. So this angle is 45 degree. This angle is 30 degree. So you can find this angle now, right? You can find this angle. So this total angle is what? So we have calculated this as 30 degree, this 30 degree, and this also we calculated 45 degree just now. So this angle is what? 180 degree minus 45 plus 30, right? So what is this? Is equals to 180 minus 180 minus what is it? Is 75 degree. So this is 5 and 100. That means it is 105. So answer is what? 105 degree. So this is how you calculate this. Okay, this is how you calculate. Understood this concept? So this was the whole purpose of this question, to tell you about the critical angle of incidence. Now let us move to the next. A convex lens of focal length f produces a real image x times the size of the object. Convex lens and real image x times. So that means m is what? X, but you can see it is a real image, so we will be taking m as minus x. And focal length is f. Okay. So he is asking us what distance of the object from the lens. So he is asking the object distance. Okay. We know m is equals to what? V by u. Right. So m is what here? Minus x, which is v by u, right? So I can write from here v is equals to minus x u. This is your first equation. We also know that 1 by f is equals to 1 by v minus 1 by u. So I can write, I need to find the object distance, right? So I will be separating object distance from this. So 1 by u I will take on that side. So this becomes 1 by v minus 1 by f, right? Now 1 by v is what? This is equals to 1 by minus x u minus 1 by f, right? So if I take like this, if I take this on the left hand side, so 1 by u, right, plus 1 by xu, right, and this is equal to minus 1 by f. So I will now solve this right here. So you can take 1 by u common on this side. So if I take 1 by u common, what it becomes? It becomes 1 plus 1 by x is equals to minus 1 by f. So if I rearrange this, so u becomes what? Minus f into 1 plus 1 by x. So this is equals to minus f x plus 1 upon. So this is your answer. That is, the answer is this one. It is coming negative. You can see this. Okay. This is your answer. So this is all about the numerical section in this refraction part, right? So this completes your this chapter, the first chapter, that is light. And you can also practice some other questions mentioned in your textbook. So I have taken some questions which are from some reference books and are some from the competitive exams. So some concepts are not involved in the NCRT. So like this sign of this critical angle I told you, right? So this can be asked in some of your competitive examination. For that, this is important, right? So this was all about the light chapter. So in the next class we will be continuing with the second chapter of this optic series, which is human eye and the colorful world. So we will be beginning with the next chapter in the next class. So thank you for today.